Happy noon. Today we will discuss about the Cmos fabrication process. There are different methods involved in the Cmos fabrication process: N-well process, P-well process, twin-tip process and silicon on insulator process. Today we will discuss about the N-well process. To start with the N-well process, it starts with a P-type substrate over which a thick oxide layer of 1 micrometer is laid. This is laid with a dry oxidation method where the oxidation is done using a furnace at 100 degrees centigrade. Above the thin oxide layer, a photoresist layer is laid and a mask is placed above the photoresist layer, and the UV light is passed through the photoresist mask and through the photoresist layer. So this photoresist layer resists the UV light region above the mask, and the region which is need to be etched off alone will be etched off. After the etching, N-type is diffused to form an N-well. So N-well is created in the P-type substrate, above which a thin SiO2 layer is laid and a polysilicon is laid for the gate of the mask transistor. This polysilicon is the self-aligning process, so it is laid above the SiO2 layer. After the polysilicon layer, N plus mask is used to mask the N-well, and the N2 heavily doped N plus regions are formed in the P-type substrate by N diffusion process, where we will be getting a heavily doped N plus region in the P-type substrate. Then N plus mask negative is used, which masks the PMOS transistor, and then it will be a P-type diffusion will be laid, and then through a boron, and P plus heavily doped source and drain are formed in the N-well. So at last we will be getting both the PMOS transistor and the NMOS transistor in the same substrate using an N-well process. This can also be repeated as in a P-well process. In a P-well process, the N region is replaced with the P, and P region is replaced with the N. So same way here, N-type substrate is taken, a thick SiO2 layer is laid, a photoresist layer is laid above the SiO2 process, a mask is placed above the photoresist and it is exposed to UV rays, and after the UV rays passed, the region which is not needed, that is the above the P-well, will be etched off, and P-type material is diffused to form the P-well process. After the P-well formation, a thin SiO2 layer is laid, above which a polysilicon is laid for the formation of gate. After the polysilicon formation, P plus mask positive is used to mask the P-well, and P-type boron material is diffused to form the P diffusion, where it is used to form the source and the drain in N-type substrate. P plus mask negative is used to mask the N substrate region, and N-type material is diffused to form the source and drain. So at last, in the P-well we have a 2 heavily doped N plus region for the formation of source and drain, and in the N-type substrate we have 2 heavily doped P plus region for the formation of source and drain. And this is the P-well CMOS inverter. So the third process which is involved in the CMOS fabrication is twin tub. To start with, it is started with an N-type or a P-type substrate over which an epitaxial layer is laid. In the epitaxial layer, an N-well and the P-well is created. Both the tubs will be formed, and a thin SiO2 layer is laid, and then a source and drain, that is 2 heavily doped N plus region in the P-well and 2 heavily doped P plus region in the N-well are created for the formation of source and drain. Then contact cuts are taken out and the metallization process is carried out. The fourth method which is used in the CMOS fabrication is silicon on insulator process, where the silicon is laid on an insulator. Sapphire is the insulating material, the base material which is taken here, over which an N-type material is laid over the entire region of the sapphire. Then an SiO2 layer is laid, thin SiO2 layer is laid, a photoresist layer is laid above the SiO2, mask is used, and the SiO2 and the photoresist layer which is unwanted in the regions are etched off. So after etching, we will be having a 2 N region islands. So only we will be having a 2 islands of N island. Then boron is implanted to one N-type diffusion to convert into a P-type diffusion by masking another one region by a photoresist. Then this P-type material region is masked and it is photoresisted, and this N-type region we implant the phosphorus to convert into a heavily doped N region. After having a two heavily doped N and P region, a thin SiO2 layer is laid, above which a polysilicon layer is laid for the formation of gate. So above the thin SiO2 layer, a polysilicon layer for the formation of gate is laid. Then a photoresist is used and masked the N region. Then phosphorus is implanted to form a heavily doped source and drain. Then this region P island is used to mask this photomask, and it is masked, and a heavily doped P-type material is implanted to form the source and drain. So we have two islands of CMOS and NMOS transistor, N device separately and a P device separately with a gate, source and drain. Here also with gate, source and drain. Metallization process is done and the contact cuts are taken out. This SOI method has many advantages compared to the N-well or P-well process. First one is the absence of well. So the transistor structure is denser than the bulk silicon is feasible. Low substrate capacitance provide the possibility for faster circuit. No field inversion problems, as if we have N-well or P-well is there, conversion of N to P and P to N takes place. That problem is avoided here. No latch up, this is the main problem which is avoided in SOI, where the parasitic transistors which are formed during the conduction of the transistor is avoided. No body effect, as there is no conducting substrate. Enhanced radiation tolerance. So these are the four different methods of CMOS fabrication. Thank you.